everybody, let's get right down to it. Today we're going to do binomial expansion using Pascal's triangle and the binomial theorem. Binomial meaning two. I have a two-term expression and I'm going to expand it, meaning I'm going to multiply it to itself 5 times. But if I did that out by hand and combined like terms, that's a vast amount of work. So instead, I'm going to use the binomial theorem and Pascal's triangle. If you have not worked with Pascal's triangle, take a moment and go check out this video. Otherwise, right now, I'm raising this to the 5th, so I am going to get to the 5th level of Pascal's triangle. So here we go. I start with a 1, and that is my 0 level. Then my first level is 2 more 1s. Now my second level is, and again, if this isn't familiar, go check out the video that explains all of this. Otherwise, I'm going to assume you know what we're doing here. So that was my second level. Third is, fourth is, and finally my 5th level is right there. Now, what those are the coefficients of my 6 terms after I multiply this times itself 5 times and combine like terms. So I'm going to go ahead and give myself 6 spaces, and I'm going to go ahead and place these coefficients there. All right, so those are my coefficients. Now, what happens next is the following. X and minus 3 are my 2 terms in each of these, and then they are going to be raised to ever decreasing and increasing powers as follows. My first set will be raising my first term, that x, to the 5th, and my second term, that -3, to the 0. Okay, when I go to my next term, this exponent is going to decrease by 1, and this exponent is going to increase by 1. But what goes inside here is going to remain my x and my -3. Okay. This next term, this decreases by 1, this increases by 1. My next term, these again decrease and increase. Keep going. And so over the course of 6 terms, the power of my first term starts at this highest power here, and so its partner is 0. So these two will always add up to the exponent you are raising your binomial to. And so then you can see how we then end up at the reverse. All right, our next step is to go ahead and do out each of these things. So let's talk about why this looks like this. 1 is the same, x raised to the 5th is x to the 5th, and anything raised to the 0 is 1. Okay, my next term, plus, right, because there's a plus between each of these terms. Okay, so again, 5, that's an x to the 4th. -3 to the 1 remains -3. Let's keep going. Okay, so again here, -3 squared becomes +9, x to the 3rd, 10. Let's do the rest of them. So check this against your work, see if this is what you got. One thing you should notice is these terms are going to alternate between positives and negatives, because when I'm raising a negative to a odd exponent, those terms are going to retain their negative. Whereas when I raise a negative number to an even power, those terms are going to multiply that negative out. And then also notice that by the time I get to here, my x to the 0, anything to the 0 power is just a 1. So now I'm going to go back through and I'm going to consolidate those terms. So 1 times x to the 5th times 1 is simply 5 times -3 is -15 times x to the 4th. So that makes that plus -15x to the 4th, or simply minus 15x to the 4th. Next, my 9 times my 10 is 90 times my x to the 3rd. Next up, -27 times 10 gets me -270x squared, and plus a negative is simply 5 times 81 is 405x. And finally, 1 times -243 is minus 243. So what would have taken us a really long time of multiplying this times itself 5 times, then finding all those like terms and consolidating them, we can accomplish using the 5th row of Pascal's triangle. And please remember, the first row is row 0. Row 0, row 1, row 2, row 3, row 4, row 5, applying those as our coefficients, allowing each of our terms to be raised to ever descending or ascending exponent powers, and then finally combining all of our numericals. All right, now let's do it again, where instead of having an x with no coefficient and then a number, we actually have a coefficient x and a coefficient y. So let's work with 2x plus 3y to the third. Okay, jam out your Pascal's triangle. Pause here if you want to see if you can get it right. We all agree this is the third row. Fabulous. Okay, let's make our 4 spots. Let's lay our coefficients in. And now let's start to put our terms in. So 2x and positive 3y are our terms, and we start with this one raised to the, that is correct, and there 3, and therefore this one raised to the, that is correct, 0, because these guys always have to add up to this power. Okay, pause the video, lay in the rest of these terms, and then come check and see if you got the same thing I did. Okay, is that what everybody got? Good. Okay, now let's start to expand these guys. So what I want to remind you here, as you go ahead and raise 2x to the third, that is 2 to the third times x to the third. So I do not want to see 6 here. I want to see, that's right, 8x to the third. And now 3y to the 0, anything to the 0 is, a cow to the 0 is, that's correct, 1. Okay, again, take a moment, pause the video, do these guys out to this next level, and then see if we're at the same place. Great, check it out. 3 times 4x squared times 3y plus 3 times 2x times 9y squared. Anybody get 6? Good. Plus 1 times 27y to the third. We good so far? Okay, let's do our next level of combining and see if we get to the same place. All right, did everybody end up with 8x to the third, no y term, because that one was the y to the 0, 36x squared y plus 54xy squared plus 27y cubed, no x term, because that was the one where x was to the 0. Fabulous. Okay, go give yourself some other ones to try, but this is the basics of how to use Pascal's triangle combined with the binomial theorem to keep yourself from having to do hours of multiplying out big binomials and combining endless like terms. Okay, check out these other videos. Consider subscribing to my channel so you know when I put out a new video. And as always, keep on mathing.